Okay, first example in section 4.3, we're asked to factor 3x squared minus 3x minus 15. And the first thing that you'll want to get accustomed to doing whenever you're asked to factor is to start with checking to see if there's a greatest common factor to any of the terms, or to all the terms rather, that are listed. So we've got 3x squared minus 3x minus 15. Hopefully you can all see that we can take a 3 out of all of those. So we're going to start there. We're going to take out the 3, and then what we're going to do is we're going to rewrite what's left when we take out the 3. When you take the 3 out of this first term, you're just left with x squared. When you take a 3 out of this second term, you're just left with x. And when you take a factor of 3 out of this last term, the 15, you're left with a factor of 5. And in 4.3, that's generally all that we'll need to do. In our second example, again, we're asked to factor, and the first thing you want to do when you're asked to factor is check to see if there's a greatest common factor. And in this case, it looks like we can take a 2 out of both of those because 8 and 2 both have a factor of 2, and we've got an x in both of those terms listed there. So we're going to be able to take out a 2x, and then we're going to rewrite what's left when we take that out. So if you take a 2 out of the 8, so we're showing what's left when we take out the 2x out of that one, you're left with a factor of 4. If you take 1x out of the x squared like we did here, you're just left with 1x. And for the second term, this 2x here, we took out a 2, we took out an x, but we do still want to leave a factor of 1. In our third example, again factoring 3x to the third, y to the fourth, minus 12x to the second, y to the fifth. So again, I'm going to start with greatest common factor. And in this case, with the 3 and the 12, we can take out a 3. And as far as x's go, we've got an x in both of these terms. But the most number of x's that we can take out is 2. We can take 2 x's out of the first term. We can also take 2 x's out of the second one. Can't take 3 x's out, though, because the second term only has 2. We can also take a y out, and because we've got a y in the first term, y in the second term, and the most y's that we can take out is 4. Okay, then we want to rewrite what's left when we take that out. When you take a 3 out of the first term, you're just left with 1. If you take out 2 x's, we're left with 1x. Still dealing with this first one. If you take out 4 y's, we don't have any y's left. So that x there is the only thing that's left in that first term. If you take a factor of 3 out of the 12, we're left with a factor of 4. You take out 2 x's, we're not left with any x's. You take out 4 y's out of y to the fifth, we're actually left with just 1 y. All right, so for our fourth example, asked to factor VC plus VZ plus KC plus KZ. So again, the first thing, check to see if there's a greatest common factor. Not going to be able to take V out of everything. Can't take C out of everything. Not going to be able to take K out of everything. And not going to be able to take Z out of everything. So in this case, no greatest common factor. And what we're going to do instead is we're going to do what's called factor by grouping. Factor by grouping. And generally, you'll do that whenever you've got 4 terms. Here we've got 1, 2, 3, 4 terms. And if we were to group the first 2, and I'll draw these sort of imaginary grouping around the VC and the VZ. If we group those 2, we could take out a V out of both of those, And if I did the same sort of imaginary parentheses around the KC and the KZ, we could take a K out of both of those. So let's go ahead and try to do that. So we're going to factor a V out of this first pairing. And if you take a V out, you're then left with a C in the VC part. And if you take a V out of the VZ part, you're left with a Z. On the second pairing, we can take a K out of that, a positive K. And if we do that, we're left with a C plus and K out of the KZ. You're left with a Z. Okay. And you might notice that this C plus Z and the C plus Z parts are the same. That's actually what we're hoping to get here. So what we can do is put the V and the K parts together. And then we're going to multiply that by that C plus Z. And that's it. Our fifth example asks to factor x cubed plus 5x squared minus 6x minus 30. So again, greatest common factor anytime you're asked to factor. We can almost take x out of everything, but we can't take it out of that 30. Nothing we can take out of everything. Then since we've got 1, 2, 3, 4 terms, we're going to factor by grouping. So we can group the first two, and we can take 2 x's out of that. And we can also group the second pair of factors. And hopefully you can see between those two, we can take out a 6. And more specifically, since we've got a negative in front of the 6, probably going to take out a negative 6 instead of just 6. So in this first pairing, we can take out 2 x's, and then we'll rewrite what's left. So 2 x's out of that first term leaves an x. 2 x's out of the 5x squared just leaves a 5. And with this second pairing, I'm going to take out a negative 6, again, because this first term is negative. It's probably a good idea. Take out a negative 6. So if we take a negative 6 out, we're left with an x. And anytime you take out a negative, the sign of the second term is going to change. So that negative 30, we're going to need to make that positive. And when you take a 6 out of 30, that leaves you with a factor of 5. And then we're back to what we had before. You've got this common x plus 5 part. And so what we'll do last is this x squared minus 6. I'm going to put that in parentheses and multiply that times the x plus 5. Okay, and our last example is a bit easier than all the rest. I just wanted to show you this just so it didn't throw anybody. Sometimes I get asked if this is as easy as it looks, and it actually is. Here we start out with this common parentheses, the c minus 2. So what we can do is put together the numbers that are in front, the x plus t, and then multiply that times the c minus 2. On the two previous examples, this was our last step, and on this example, that's actually all we need to do.